Welcome to another Cryptotesters live podcast. Today I have with me no one less than Eli from Starkware. I'm super excited to have you, Eli.
Hi.
I have been researching about zk-Rollups for the past couple of weeks. I'm still a noob, but at least I'm very like my interest is peaked now, and so I have a ton of questions for you. Maybe let's start with the beginning years of Starkware. So you have a super impressive background. You had like research positions in a lot of the most prestigious universities in the world. And I'm just wondering, how did someone like you get into the crypto space, in around 2017, 2018? At least that's when you found Starkware. Maybe you were in the space before. But I'm wondering, what did you see at a time where there was only ICOs and scams? You believed in it, you saw the potential.
Well, I actually started, I swallowed the red pill a few years earlier. I was doing indeed research about validity proofs, about cryptographic proofs of computational integrity that we'll get into a bit later. And the eureka moment for me was when I attended the Bitcoin conference in San Jose in 2013, May 2013. And what happened was I was basically going around academic institutions at the time, peddling my research and saying, my collaborators and I have started working on implementing these cryptographic proofs. And here's a bunch of use cases for them. And all of the use cases I had came from the conventional world, IoT things, about nuclear plants, or gaming in the conventional world, and they didn't quite make sense. I incorporated just one example about Bitcoin, and I got asked to speak at the Bitcoin conference there, and I was just blown away because there was this immediate feeling of love at first sight, that the kind of technology we were working on is a very good fit for decentralized blockchains because of their trust assumptions. And ever since then, I've been following this path. So I was among the founding scientists of Zcash, which used privacy of cryptographic proofs. But we had this better technology called Starks that we knew could do a lot, both in scalability and also in privacy. So I had this bug in me. And 2017, late 2017 was like a really good time to, the technology was ripe. The time was frothy. So we jumped and co-founded it. We're four co-founders of Starkware. Dr. Michael Ryabtsev was a PhD student of mine, and he's a co-inventor of Starks. Professor Alessandro Chiesa, then Berkeley, today at the Starks and IOPs and things like that. And Uli Kolodny, co-founder and CEO, came from the business side, and we co-founded it back in 2017.
Very cool. And so you basically saw the potential the first time at the Bitcoin conference, but the Bitcoin community was not interested in adopting this technology.
They were very interested. So Greg Maxwell, like the day after, said that gave a bunch of applications. Mike Hearn was very enthusiastic. They were very enthusiastic about it. I think they still are very enthusiastic. And I want to say that I would really, really want Starks to also go on Bitcoin. It's just a matter of Bitcoin moves. It's very conservative, and I have no problem with that. So like inserting new things, it's not Turing complete. You would have to go through a very long process to allow our technology to sit on it. I'm sure we're going to get there, but it's just that, it takes time. But I think they were very enthusiastic about it and still remain. This is technology that very much goes in line with Bitcoin's core principles.
Makes sense. And at the time, you didn't believe in mainstream use cases for this type of cryptography. Has that changed today?
Not yet. The reason is that, think of your bank, So you would like your bank to prove to you that it is handling your funds with integrity. But if you are too weak to come to the bank and say, hey, bank, prove to me that you're doing things with integrity, that you're standing by certain principles, they won't do that. And you won't get your politicians to make them to do that. Right? It's basically a trust-based system. They'll say, what do you mean? We have all of these, people in suits who are taking care and auditing us, and, the big four companies are auditing us. Why would you even want us to prove something to you? And on the other hand, the bank is not going to trust you no matter what with you handling your funds and proving stuff to them. the bank basically says to you, look, we will do all the computations that are related to your finances. The only thing you're allowed to do is basically open an encrypted channel to us through your app, and then just tell us what you want us to do for you, and we will do it for you. So in the conventional world, we're just not there yet. We'll get there through blockchains. But the conventional world doesn't yet understand why proofs are really, really needed by society.
Yeah, it's sort of funny because you were a professor in computer science and probably also this type of cryptography that you're using today at Starkware, and you've had a bigger impact on sort of the adoption and mainstreamness of this technology by commercializing it than you ever had as a professor, because nowadays suddenly like Twitter influencers talk about what ZK Starks are, and it sort of seems like it's, and even I am researching about it, so you have definitely achieved something there.
It's a different sort of time frame. As scientists, you think very long range, and you're fine with a lot of quantum mechanics is based on complex analysis and imaginary numbers. So the mathematicians who discovered or invented these numbers and concepts done very foundational work that later on was commercialized is the basis for all of lasers and photonics and electromagnetism. But it's sort of the time scale you're looking at. And people are happy about. I was very happy as a researcher. Was completely content with not having any Twitter persona. It's also fun to be out there today, but.
For sure. Talking about commercializing, when I look about or at the different ZK teams like Loopring and so on, I see there's a big difference in go-to-market strategies. For example, talking about Loopring, it seems like they built like more a decentralized exchange that uses their ZK technology, but it has it uses their branding very strongly. And then you have zk-Sync, which was focused on a payment technology as their first use case of the ZK technology, which was used by Gitcoin. I think Gitcoin is the only one using it, maybe others. And then I think Mina, that's entirely a new approach. Again, it's more like building a layer one. And you guys, you've more stood in the background and enabled other applications to scale their business logic by using your technology. Was that a conscious decision, or how do you see that?
Yes, it was very conscious. We wanted, and we still are saying that we want to focus on the things where we think our added value is most concentrated. So, for instance, I mean, you mentioned Loopring. We are very friendly with them, and I have a lot of respect for them, both technologically speaking, and also as a product and as a customer-facing team. They're really, really, really good. They move very fast. They're very professional, and a lot of respect and appreciation for them. They are customer-facing, which means a lot of things, right? It means you need customer support for. You need to build an interface and a front end for users to trade on, and all kinds of things. I completely, the main advantage of that is that you completely own the vertical, and you're doing something that you completely control, everything from the customer acquisition all the way to the technology stack. We wanted to focus only on the technology stack, which is why we are in our Starknet systems where we work B2B, business to business, so that we are not doing customer-facing stuff. And then also Starknet, which we just launched, is also not quite B2B, it's B2D, as in David, business to developers. We are basically opening a platform that end users don't quite, interface with, but we hope that developers will be building on and using as a technology. That's just our comfort zone. We think that that's where we are best at, and we have very limited resources. We want to put them focusing on what we do best.
Yeah, and it scales better, no? Instead of building just one business, you have a multitude of businesses that come to you, and the chances that at least one of them becomes very big is higher, I guess, than if all you
It's a trade-off. It's really a trade-off, because on the other hand, we're very dependent, right? Because we're not customer facing, there is the risk that that some businesses could infrastructure. Some of these businesses could decide that they're not happy with us and replace our infrastructure with some competing infrastructure, and they own the customer-facing side. So we'll be sort of cut out. So there are pros and cons, but the main reason that we went this way is not so much the business, it is the focus. We want to focus on building proving systems, verifiers, general computation using those, and offering tools to developers that make this accessible. So that's really the reason that we went down this path.
Why do you think you had such success at attracting different applications? So listeners might know that DYDX is using StarkX, Diversify, and Immutable, probably more that I don't know of. But these are already three very big apps that use you guys. And what do you think made them choose Starkware or StarkX?
I think that where we are really, unique and excelling at is we are very focused. As we just mentioned, we know we are focused on the areas where we think our added value is most concentrated. So we understand ZK Stark provers and verifiers and the whole technology around them and building systems using them. So almost all of our effort is basically on making these things performant, production grade, and accessible to as many different teams and developers and so on. So one is like focus and like strategic focus to say this is the thing we want to do, which means that we'll say no to this, that, and that, right? Because we want to focus only on this one aspect that we think is most important. The second really important aspect, I think, is that we have a very experienced team at several levels, both in engineering, in product, in management, in business. We are, this is, it's sad to say, but we're not that young. And many in our team are sort of experienced, having, decades of experience in various domains of engineering and business, so on. And I think we built a very robust team. And it's, you look around at crypto, you see a lot of amazing financial successes. And then when you look at the sort of the size of the team and the years of experience and how they're built, you see that sometimes they are strained in sort of, right? It's a small team of relatively inexperienced, very, very smart and talented people, but then suddenly, boom, something went, exponential and ballistic. And some of them have these sort of growing pains. So I think this, being a bit more seasoned and focused and experienced is another thing. And I think the most dominant factor is just that we have this, we never compromised on excellence in hiring. And when it comes to growing the team and building it, we never compromised on the excellence of people. And if we could have hired 3 more, but we wanted someone really excellent, so we just went for less. And we just ended up with this just amazing team on, math, science, engineering. So I think all of these 3 factors, the excellence, the focus, and the experience are, I think, playing out here.
And having been a professor probably helped you for the last part, the hiring, right? You just poached all your best students from back at university.
Some of the students did. Most notably, one of my PhD students is a co-founder and chief architect. That's Dr. Michael Ryabtsev. Another co-founder is a highly esteemed researcher who's been doing amazing stuff, Professor Alessandro Chiesa. But excellence begets excellence, right? So it's far from just being students. It's just excellence begets excellence.
Right. Yeah. And everyone knows that you guys you build layer 2s or scaling solutions. But can you explain how the solutions that you build, how they actually allow applications to scale? What is sort of the high-level overview of how this technology works?
So the whole point of an L2 is to say Ethereum is this amazing general purpose computer that is replicated many, many times and is very trustworthy because of its decentralization. But it is also extremely limited in terms of its clock rate, if you think of it as a computer. Everyone wants to use it. It's such an amazing success. Everyone wants that computer to run their logic. Okay, so you have this like prime real estate. Think of it as like this location, I don't know, center of Manhattan or whatever it is, center of some big city. Everyone wants stuff to be there. So this is not a good place to put your manufacturing and all the stuff that takes a lot of time and effort. You definitely want that offshore and to use this prime real estate only to display some succinct representation of what's going on. So what layers 2 do, generally speaking, is they find various ways in order to do a lot of the work not on this computer that is Ethereum, but elsewhere. And the tricky part is like, how do you make it as secure as Ethereum? Because someone could just say, hey, just give all your information to me and I'll just run the computation. And I mean, this is called proof of authority. This is the good old system of banks and whatnot. You just give all the information to one party. It operates at extreme efficiency and you trust it. So what distinguishes layer 2s is that they say, no, we want the security level to be exactly that of Ethereum's, yet have a much greater scale. So that's what L2s do in general. If you want, I can explain a little bit how our particular L2 technology works and how do we manage to pack more scale without compromising on security.
I would love to, yeah.
Okay, so roughly what we do is, here's a first approximation. We say, what if this computer that is very important and very trustworthy and very slow, which is Ethereum, could be used to sort of do these random audits of huge batches of transactions and still have it be secure. So like, 100,000 transactions need to be processed. Let them be processed elsewhere, and then use the Ethereum computer to sort of sample and check here and there that everything was done correctly. So this is exactly how our verifier works, the Stark verifier works, exactly how it works. The only tricky part here is, well, if I had 100,000 transactions, and then I'm sending the Ethereum computer to check at a bunch of places, let's say 10 places, how do I know that all of these 100,000 transactions were done with integrity? So that's where the math of Stark and like the moon math and the deep science and cryptography come into play. You ask the party doing the processing those transactions to encode them in such a way that when the Ethereum computer comes and inspects it, if there's any problem, it will be immediately seen from these random inspections. And that's where the magic and the wonder of mathematics comes into play in making this possible. So we have a system where on the L2, there's a computer that doesn't have to have any trust assumptions. It could be run by Darth Vader, and it processes like hundreds of thousands of transactions. And then it submits some statement to the main chain and says, look, everything I done was done with integrity. And now Ethereum sort of samples a random number of locations of some huge transcript that represents the computation. And the wonder of the Stark math is that if there was even one mistake or one omission or one thing not done correctly in all this huge batch of these small number of checks, something's going to come back and say, look, this doesn't look well. And then you reject it.
Gotcha. So basically a transaction is final on a layer 2, on a StarkX, for example, the moment this batch is posted onto Ethereum layer 1.
Yes, the moment it is verified on Ethereum layer 1, it takes a little bit of time for it to be verified. Once a batch is verified, you know with near certainty, with cryptographic certainty, that all of the transactions included in that batch were done correctly.
Okay, yeah, that makes sense. And so you have these different flavors of zk-Rollups that are in production today, right? So there is one term that is often floats around when people talk about these zk-Rollups is data availability. Do you want to walk us through what this term means and why it's important in the context of rollups?
So the question, I mean, they're like, if you look at the Ethereum gas cost, there are three things you pay for. You pay for Ethereum storage. I mean, that costs a lot. You pay for Ethereum computation, and you pay for transmission, okay? So what the validity proofs help you with is in removing the computation completely, and then they don't affect the storage. So you still have a problem of data. Like, how are you going to keep the data? Even if the computation was done correctly, maybe the state of your system just completely disappears, and then you're in trouble. Okay, so there are several different ways to solve this problem, and one of them is to say, let me use Ethereum's transmission, which is cheaper than Ethereum storage, in order to broadcast the sequence of state updates. So my information is, the state of the system is maintained off-chain. Mm-hmm. The only thing I do is I don't ask Ethereum to keep this state. I do use the transmission in order to transmit updates to the state of the system. And this is called a rollup. Second option is to say, basically, people using this are going to have their data stored completely off-chain, which means that if something, just completely horrendous happens and all of the off-chain system disappears, then they might be in trouble, that their data does not exist anymore. So even though it's valid, no one knows, where your balance is in the state. So in order to circumvent this, there's a notion that basically we innovated on, which is the Data Availability Committee. It is a small set of parties that keep replications of the data, so that if even one of them remains alive, even if everyone else crashes, you can still have your data. So now this is a compromise on security, right? Because you don't have the assurance of L1 security, but it is a compromise that also allows you to save a lot of money, because now you don't have to use even transmission on L1 in order to update the set of the system. So it's a trade-off. And the third option is volition, which allows you on a user per user basis to decide whether you want your data staying in roll-up mode, which means that it costs more but is L1 security, or if you're willing to compromise temporarily and put it to the Data Availability Committee hands, and then you pay less. And you could decide, let's say once a day, you want to move it back on-chain, and so on. So that's basically the whole spectrum.
So the roll-up mode is basically, if we use that Ethereum as a computer analogy, it's basically saying, hey, let's just use the hard disk of the Ethereum computer, but move the execution onto another system where it can be done much more efficiently. And then not in the volition mode, in the Validium mode, you have this data not even on Ethereum anymore, neither the execution nor the data, but you use sort of like a data availability committee, and so this basically is not using a blockchain at all anymore, right? This Validium,
Validium keeps the data on a data availability committee, so it's replicated among a bunch of data availability providers. Right, that's how it is in Validium. And then you pay less, but you are not as secure as L1. You are as secure as the Data Availability Committee, as the strongest Data Availability Committee member.
Okay. And so what is a sufficient set of security for such a Data Availability Committee?
So we need, we of our 4 customers on StarkX, 3 of them use Validium, and one of them uses Rollup. So DoIDX works in Rollup mode, but Sorare, Immutable, and Diversify work in Validium. Each one of them has a different set of data availability providers, something between 5 and 10. There's a certain threshold, and basically, for a system to be updated on L1, you need a sufficiently large number of members of the Data Availability Committee to sign that they have received the latest set of the data and they keep it. And we think it's a fairly reasonable security guarantee, and I think, our customers think that it's so, but it's really something that users and customers have to decide on whether they. From our point of view as Starkware, we told all of our customers, you're free to choose if you want to work in rollup mode or in Validium mode. And very soon, within the next month or so, we'll also offer volition for our customers. So they can offer their customers, whether each individual customer chooses to keep her data on-chain in a rollup or off-chain in the data availability. And we think this is the best offer to put it back in the user's hand.
Why do you think the existing customers have chosen one over the other? Is it, has it something to do with DYDX handling very large amounts of money versus immutable, just some like low cost NFTs, and that's why like a low security is fine? Or
I can mention several considerations. You're definitely right that the larger the stakes, the more you should lean towards rollup as opposed to Validium. Another consideration for some of the customers was actually one of privacy. If you are in Validium, there's less information that is leaked out to L1 about what's going on. It's not zero knowledge, and you can learn a lot if you really, really want to, but it's slightly less public than in rollup mode. So privacy is another consideration. Security is a consideration. And of course, the third consideration is the cost to the users, because rollup just costs a lot more to users than and you're right that like for an NFT, it doesn't make a lot of sense. You really, especially for low cost individual NFTs, like the kinds that are, trading cards in a game that probably cost whatever, $50 each or a few dollars. It's even the, if it's, let's say 20 cents to pay for the data availability, that's already a considerable cost. And maybe you're better off using Validium and paying less than a cent for the data.
Yeah. That makes sense. And going forward, you will launch this more like open and public Starknet, where general computations are possible and applications are composable. How do you think this will affect the apps that run on StarkX today? Do you see, or even so the existing ones, but also future ones, do you think that still in the future some customers will come and say, hey, we want to build on StarkX? Or is it a no-brainer to always launch on this more powerful Starknet?
The main, so first of all, Starknet is already live. Those who want, I'm just typing it here. If you just go to Starknet.io, you can, this is the place where you can join and start deploying on. So the main reason behind launching Starknet is that with all of our 60 very talented engineers, we still can't come close to servicing all the need that is out there for blockchain and scalable blockchains. So we built, we invented in-house and developed a whole programming language and tool chain that allows basically people to write any application. We wrote the logic for all of our systems. All the StarkX systems is written in this pretty amazing programming language called Cairo. Executions of programs in Cairo are automatically Stark proved. So you get this whole compression of computation effect out of the box automatically without needing to learn, the advanced math that goes behind the generation of Stark proofs. And we thought that the best way to increase and maximize adoption of this amazing technology is to make it accessible to everyone to write basically their logic. So that's the rationale behind Starknet. And we're very, very excited to see the amount of traction and adoption that it's already receiving. It's basically live just like 1 week, and it's already getting a lot of traction. So that's very, very nice to see. Now, you asked about what will happen with our StarkX applications as we go forward. This is a very interesting question that we're spending a lot of time thinking about. And we actually have some very interesting directions in how to merge the two. And stay tuned. We'll basically, follow us on Twitter and so on. We'll be writing some interesting thoughts on it. I don't want to divulge just yet, but if you follow us on Twitter, you'll definitely see some very interesting things on how to make StarkX and Starknet work together.
That would be incredible if all the applications in all the state, all the balances, all the users would be on Starknet, you immediately have bootstrapped a network with strong network effects and users and so on. So because nowadays, so I'm using I'm using Diversify and DYDX quite a lot. Haven't gotten around to use Immutable yet. The one thing, and it's insane how nice the UX is, but the one thing that is missing is the composability, right? We're so spoiled on Ethereum to you just move our funds from A to B, and applications leverage each other. But then on DYDX, it's your funds are kind of stuck there, and it takes time and it's costly to get them out. And it would be so nice if I could send them from DYDX to Diversify and obviously other applications in the future. But you think that StarkX is more a transitory technology that got you to Starknet? It will not be used a lot in the future by new customers.
I think so StarkX is a standalone L2 technology that reaches extreme scale and is a single standalone application. And we think that going forward, a lot of customers out there are going to want such things, like when one day when banks and payment processors come along, a lot of gaming companies and so on, they probably want some very high throughput, completely in their discretion and control system that they can operate on. So I don't think StarkX are going to disappear anytime soon. If anything, we'll see more of them. But at the same time, I think Starknet, which just launched last week, is going to get a lot of traction and a lot of things built on it. And what we're thinking very deeply about, and as I said, we have some interesting and surprising things to say about that in the coming weeks, is that we'll try to find ways in which you can have your cake and eat it as well, meaning that both you'll have customers that can have all the speed and the advantages of StarkX standalone systems and all the flexibility of having those, alongside with the interoperability and composability and the network effects of Starknet.
And do you think there will be one Starknet, or will there be several? And I'm asking this because I saw, for example, Arbitrum, they have Arbitrum 1, right? And then supposedly Reddit will also launch on a Arbitrum rollup, but a separate network. And apparently there's some reasons why some big companies sometimes like that. Do you think that will be the same for Starknet, or will there be just one?
Well, I think one of the reasons that I'm guessing Arbitrum are doing this for Reddit doesn't exist in our case, which is that fraud-proof technology doesn't scale as well as validity-proof technology. For instance, in fraud-proof technology, you need to put all of the witness data on chain, and there's longer finality time and all kinds of things. So I can totally see how a fraud-proof based system that tries to cope and service the just unimaginable huge amount of information and transaction that Reddit would need to service all of its users would probably want to build a second, more dedicated system. The nice thing about validity rollups, such as Starknet, is that they can handle ever-growing sizes of scale and TPS in a much more streamlined way and without necessarily opening new Starknets. So maybe there will be more than one Starknet, and probably for privacy reasons or something like that. But there's a good chance that you'll see one big Starknet that still has the ability to have, a lot of different applications on it, including large-scale throughput and things like that.
Yeah, because I've often heard also the argument that if we really want cheap transactions on rollups, and I don't know if this also applies to zk-Rollups, but at least for optimistic rollups, it would be best if there's a multitude of these optimistic rollups, and then usage is spread somewhat evenly across those? Because if it's all if all the usage is concentrated on one, then you will have like a fee market developed there, such that potentially people start bidding as much as on layer one, and it just goes up. Whereas if it's more spread out, you don't run into those issues. But I don't know if that also affects for.
Optimistic rollups are, you could compute what is an upper bound on the limit of total optimistic rollups that could go. And the way you compute it is you say each time there's a transaction, there's at least one signature. So I'm putting a very crude lower bound. And this signature must go on L1 because that's how optimistic rollups work. You need to have all the information needed for anyone to challenge a fraud proof. So if you just take the amount of gas, convert that into how much transmission there is, and then convert that into transactions, you get an absolute upper bound on the amount on the TPS that all optimistic rollups, doesn't matter how many different are running, if you parse them one way or another, can have. So you have an upper bound in terms of L1 capacity on fraud-proof L2 capacity. Now, this is starkly different with Starknet. You don't have this upper bound. You do not have, so theoretically speaking, there's a nearly unlimited number of transactions that could be supported on an L1 as it is today through Starknet. So there's a very stark difference between fraud-proof limits of scale and Starknet limits on scale. One is bounded in a very concrete way, and the other is pretty much unbounded.
That's good to hear. And how do you think about these? So what I heard is that to develop applications and tools and so on Starknet, you have to rewrite them in Cairo, which is your own programming language. Do you think it will take a long time to build up this tooling to work with Starknet? Because I for example saw that the wallets don't work exactly the same way than on like an EVM chain. So I'm wondering, is all the applications that have been developed and so on, do they all need to be written from scratch?
So no, they don't have to be written from scratch. There's first of all a transpiler that will be available very soon called Warp by a separate team. I mean, it's part of the Starknet ecosystem, but it's not part of Starkware. And that's one option. You'll see a lot of wallet integrations out there very quickly. Starknet is live like 1 week, and I think Argent are very, very close to either posting or have posted so like 1 week out, and you already have some wallet support very, very imminently. I'm sure there are going to be others that are going to support this. So of course, like any new system, you're going to have a period in which infrastructure is built. I think it will be weeks and months, not years. And then you'll have everything you need as a developer to start building. I mean, you have pretty much most of it today. You can start building, but some other aspects will need to wait.
Crypto moves at light speed anyway, so it will probably be quite fast. And do you think that these teams that, in the case of Starknet, it's Starkware Labs, or I think that's how you call it, and do you think the moat is strong? Because I've seen, for example, in the optimistic rollup space, there's so many forks nowadays of the OVM chain built by the Optimism team. I think there's 4 teams already that have forked it. Do you also see that happening in the zk-Rollup space? And if yes, what would you think about it?
So there's there are a lot of teams out there. They're really, really good. There's you mentioned, there's Loopring, there's Aztec, there's zk-Sync, there's Mina and Mir, there's Maiden, there's Hermes. Some of them are using technologies that we invented, and some of them are using technologies that other teams, like most notably Aztec, invented, and that's really cool and great. I'm sure we're going to see more forks and uses of this. I'm not worried as Starkware by these things. I'm encouraged by them, and I think it's really, really great. I'm very supportive of all teams that are building new and innovative validity proof technologies. And I'm even more excited about teams that are using the stuff that we invented and doing so. I think that's really great. So I guess at some point there'll be competition, but right now there's just so much more to gain from collaborating and seeing that others are also advancing the field.
Yeah,
that's our approach.
That makes sense. I also read one take that said that the mode of these rollups is actually quite strong because the batches that you have to submit to L1, basically the fuller they are, the more transactions, the more transactions and the more apps you have on your rollup, the more economical it becomes to batch very regularly, thereby offering a better user experience to users because faster finality and I guess faster withdrawals back to L1 and so on. So this person was actually saying that this will even be more the case in the future where Ethereum as an asset will be more costly, L1 block space will be even more costly, and so it will be super hard for new entrants to build a completely new rollup from scratch unless they are like VC subsidized.
Yeah, I think it's going to be hard to. Yeah, I mean, we've been at it for 4 years, and we're now a team of 60, and we're only an alpha. It's a lot of effort to build a good production grade system that customers can trust with a lot of funds.
How long do you think will this transition take from? Right now we're in this awkward phase in Ethereum where there's still a lot of the execution happening on L1, and it shouldn't be the case. Like it's not what it's built for. And then you have always these people posting screenshots of like a $2,000 NFT mint or whatever. But yeah, and we need to gradually shift like execution to layer 2s. How long do you think this transition will take? And do you think it will get to a point where there's nothing anymore on L1? It's literally just like data availability, but there's no DEX anymore, nothing. I have a hard time conceptualizing how that will look like.
So I think we need to take this. Look, I think we're nearing that phase. So this is already in the works. Meaning, I think the daily volume on, for instance, DYDX is higher than that of Uniswap. So like an L1, the number one L1 DEX is I think seeing less volume than the number one L2 DEX. I think this will only become more extreme in the coming months. On Twitter, I offered Dankrad. I mean, there are all these claims that I find strange, that it's going to take years for validity rollups to do this or do that. I don't know where these claims are coming from. We are effectively today on our applications running a TPS that is significantly higher than all of Ethereum's and Bitcoin's today. This is not in the future. And so, okay, it's true, it's for dedicated applications. But I offered publicly Dankrad to make a bet that in 12 months, in the next 12 months, Starknet, the general purpose computation layer, will flip in Ethereum in terms of compute. I'm sorry to say that my offer to place a bet was not accepted for technical reasons, but I'm still willing to put this bet against anyone to offer some metric. How do you compare sort of transactions here and there? And I think that within the next 12 months, Starknet is going to flip in Ethereum in terms of compute load. And this will join what has already happened for dedicated systems, in which our L2 systems on StarkX have already flipped compute for Ethereum and Bitcoin. This is something that has happened. I mean, crypto Twitter is not aware of this, but this has happened in the past.
Yeah.
Already there.
Well, yeah, I wouldn't take the other side of this bet either. But yeah, talking about mode, I've heard also people saying that these layer twos, once they gain like huge scale, they could at some point become self-sustaining networks. Do you think that's a realistic path for a zk rollup to start as a layer two? Okay.
Yes.
Okay.
Completely plausible.
What would that look like?
Could happen. Well, I don't know yet because, as I said, we're very focused. So we see one thing at a time. But I'm just saying, contemplating, suppose, sometime in the future, suppose that both in terms of volume and value locked and, 3PS and any metric you care to choose, the amount of data, the number of developers working on, suppose you have some L2 that is on par with or greater than the L1, which it's using for security. Then from a completely rational game theoretic point of view, this L2 should be thinking about, what is its security based on, right? Because if the security is based on the security of the L1, that, especially in a proof of stake system, that might make sense if the cumulative stake value of the L1 is far greater, 10x or more than that of the L2. But if they're roughly on par, then you would be at some threat if you don't sort of react to it.
I see. Okay, you mentioned security. That's probably quite easy to measure. Like security as being one thing to look out for in order to make that choice, whether to become independent or not. And I guess security is easy to measure, like economic security. But you also mentioned, if you become far greater in terms of users, developers, and so on, isn't that the point of an L2, that it becomes far greater than the L1 in terms of apps, users, and developers?
You're right. And then you're right. So then the question begets, like, what is the relation between the L2 and the L1, right? Because the L1 is used for security, but if already everything is happening on the L2, then I think like two things might happen. First of all, that L2 might just look for ways to tie itself to more than one L1, right? Which both for interoperability and for increased security and more users and more use cases. So that's one option that is worth exploring. Of course, it raises a lot of interesting research question, which is what happens if the state on one L1 differs from the state on another L1, and how do you deal with that? So, but I don't think it's a completely insolvable question, right? You could think about that. And also, yes, it does raise the question of how will the users of that L2 think of their relation to the L1? Like, what is the role of that L1? So that's an interesting question that again is left to the future.
So what is it in an L1 that an L2 is looking for? I mean, again, we mentioned security, but for example, in the case of Ethereum, the whole roadmap has been now like shifted towards optimizing or making life easier for rollups, optimizing their efficiency and so on by increasing the amount of, or making call data cheaper in L1 blocks and then various measures that I wouldn't even be able to. Is Ethereum, by making all these accommodations in the roadmap to make rollups more efficient, would it be easy for Starknet to just deploy to another L1?
Nothing is easy, but nothing is easy. Even deploying onto Ethereum is not easy, right? It took us 4 years and again 60 developers and a lot of time and effort. So it's not easy, but it's definitely theoretically possible to deploy. Again, it raises all kinds of questions of how do you what happens when the two L1s disagree and various other things. But yes, it is possible to conceive of a system that talks to more than one L1. So you asked like what will be the role of Ethereum. So I think definitely Ethereum will be, as an L1, will be used for security. It's also going to be used for like as a communication layer to other L2s.
True. So in a world where there's a multitude of rollups that are all thriving, and Ethereum is the settlement layer and communication layer, the messaging hub to these other ecosystems. In that scenario, Ethereum is sort of irreplaceable from Starkware's point of view, because you want to be able to speak to these other chains and rollups. So basically, it would, in order to become irreplaceable, it would be best from Ethereum's point of view to have like different ecosystems that are all have success.
Yes, from Ethereum's point of view, I agree. Yes, yeah. I guess you asked about irreplaceable. I don't know, like there's a statement saying that cemeteries are full of irreplaceable, individuals. So I guess nothing is quite irreplaceable. But
cool. Let's maybe finish with talking about Starknet, which you just announced, I think, beginning of this week or last week as a sort of alpha release. And what can we use today? What we'll be able to use in the next couple of weeks, and what to expect?
So today you can write smart contracts and deploy them. Initially, we have a whitelisting mechanism, just like Optimism and Arbitrum, because this is still in alpha mode, and we want to make sure that our systems don't have bugs and we understand what's going on. So in the coming weeks, you'll start seeing various bridges for various ERC20 tokens, so people can start moving funds and using those applications that will emerge there. You're going to see probably some gaming applications coming online. You're going to be seeing some wallets like Argent integrating with it, and from there on, it's anyone's guess, like what will be, the killer app that goes there that cannot be done because of computation limits on L1 and will sort of skyrocket there. I really don't quite know. If I had to guess, I'd guess it'd be something with gaming and NFTs, but generative art maybe, but I'm not sure.
Cool. We'll see. I know already of one game that is going to launch, right? It's Dope Wars.
Yes.
Yeah.
A lot of people are following that and have high expectations. Maybe that.
Yeah. When we talk about games on Starkware, what does it actually like? What parts of games will be able to run on chain basically, or on Starknet? Because on Ethereum, when we say like blockchain games, we just mean that there's like some items that are NFTs and they can somehow be ported into like this like game, but like
what's
the
nice
computations.
So what's
the
nice about?
you go.
Sorry. Go ahead. I interrupt. Please go ahead.
No, I was just going to say the computations that are part of the game, they are not on chain, right? And so I was wondering if the game logic would change on Starknet.
Yeah, so the reason that so little of the game logic or none of it appears on L1 games is because just L1 computation is very limited, as we said at the beginning of our chat. And Starknet removes that limitation. So now there are a lot of projects that are looking at generative art and gaming that are planning to use Starknet for also doing some of the computation. So, for example, there's this Guilty Gyoza, a very brilliant developer who's been building a physics engine and an AI engine, and sort of all of them are being executed on Starknet as smart contracts. And the reason he can do this is because the cost of running computations on Starknet is not that high. So I think we'll see more logic, gaming logic, generative art logic, CryptoKitties kind of things being generated, but with more elaborate code happening on Starknet.
Cool. Well, I'm super excited about all of this. I already downloaded the Argent developer wallet just before the call, so I don't know what I can do with it yet, but I'm sure whenever there's something, I'll test it. And yeah, thanks so much for this call. I
Thank you,
really
Luther.
enjoyed it.